Hello mathematicians. I'd like to simplify this algebraic fraction. Well, first we'll rewrite this as a product of these factors. So we have 16 over 24, we have m squared over m cubed times n over n squared. So if we simplify this, we divide both the numerator and denominator by 8, we get 2/3. Now we're dealing with indices. We have m squared, and we'll take this m cubed in the denominator and take it up to the numerator. It becomes m to the minus 3. We'll do the same here with n. This is n to the 1 times n to the minus 2. 2/3 stays as it is. Now we're going to add indices because the base is the same. This is the rule. So now we have m to the minus 1 times, here again, we add indices. We add +1 to -2, we get -1 with the same base, so we have n to the minus 1. And now we can simplify this. 2/3. M to the minus 1 is 1 over m, and n to the minus 1 is also 1 over n. So in the numerator, and this is the numerator because this is m to the minus 1 over 1, this is n to the minus 1 over 1. We take it into the denominator, it becomes positive. So this is m to the 1. We don't write the index 1, and n to the power of 1. We put it all together, we have 2/3 mn. And let's just write this, 2/3 mn. And this is our solution to simplifying this. First, we decompose it into factors, integers, and we also group like terms. Then we simplify until we end up with the simplest form. Thanks for watching this video. Here's another algebraic fraction that we'd like to simplify. Again, we'll separate our terms, integer terms, and this is multiplied by x to the 5th over x squared times y cubed over y squared. We have a factor here of 3, and we have indices here, x to the 5th. This becomes x to the minus 2 when we take it into the numerator. X to the minus 2 times y to the 3rd times y to the minus 2. 3 times, we have x cubed, because we're adding indices. 5 added to -2 will give us +3 times y cubed times y to the minus 2. We add indices, we have just y. And so our solution, 3x cubed y. The simplest form of 24 x to the 5th y cubed divided by 8x squared y squared. How do we go about simplifying this? They've decomposed it, so we'll try and put it together, but before we do that, we'll gather all the integer terms so that we can see what we're doing. Here we have 8 times 5 is 40 times 2 will give us 8 in the numerator, and in the denominator, well, let's work out the Let's work out what we have with the terms. We have pq squared m and then rs. And so now in our denominator, we have 15 times 4 is 60, times 3 is 180. And in the denominator, we have rs q p squared. To tidy this up, we can get our 80 over 180. We'll put rs over rs. So we'll separate this again just to make it easier to see. We have p over p squared. We have q squared over q. And we have m on its own. When we simplify this, we divide by 10 first, so we have 8 over 18, and then finally we divide by 2. And we have 4 over 9. So that's our integers then. This cancels to give us 1. Now we have p to the 1 power, and this is p to the minus 2 when we take into the numerator. And here we have q squared times q to the minus 1, and we have m. This simplifies to 4 over 9. We bring it all together. This will give us p to the minus 1, which will take us into the denominator to make it p to the raised to the 1 power, or the first power. We'll have m in the numerator along with q, because this is q to minus 1, which is q to the first power, q to 1, which is q. So we have q, m. And this is our simplified version of this algebraic expression. Let me just write this so you can actually see it. 4qm over 9p. Just to recap, we cancel here to get p, because we add the index 1 to minus 2, we get minus 1, which is 1 over p. And we have p there, 1 over p here. Q to the second power times q to the minus 1, we add indices here. We end up with q to 1, which is in the numerator. And m stays as it was at the beginning. So our solution of the simplified version of this is 4qm divided by 9p. Thanks for watching this video. My name is Alistair. Bye for now.